So this is an exercise involving the law of demand. And the law of demand is that there's an inverse relationship between the price of something and the quantity of the something people want to buy. We have somebody by the name of Daniel, and he's got $24 to spend. And there's 3 goods he can buy, and they're good A, artichokes, good B, burritos, good C, coffee. The table shows the quantity of each good, A, B, and C, and how much marginal utility the person gets when they consume that good or service. And the marginal is the additional satisfaction a person gets every time they consume 1 more unit of the good. So this person consumes 3 units of good A, how much total utility will they get? Total utility from 3 units of good A will be the utility from the first plus the utility from the second plus the utility from the third, up to 120. That's the total utility they'd get from 3 units of good A. And 3 units of good B would give them 75 plus 60 plus 40, that's 175 units of utility. We call those utils. And that's a problem that some economists have with this model, is that people have to be able to measure their satisfaction. When in reality, people don't put a number on satisfaction like this. And that's the beauty of the indifference curve model, because you don't have to make that assumption about people's behavior. But on the other hand, if a model is useful and yields good predictions, then who cares if the assumptions are all that unreasonable? That's what some economists think. But where was I? MU is the margin utility of A, B, and C. So this person, Daniel, has $24, and he has to decide how much A, how much B, and how much C to buy. And that's going to depend on the prices. The price of good A is $2. The price of good B is $3. The price of good C is $1. Those are the prices of each good. So Daniel has $24, and he has to start purchasing things to increase his utility. So what is he going to purchase first? Well, a mistake students make. Sometimes they don't do this. Is to just look at the margin utility numbers and look for the biggest one, which in this case is B. 75 is more than 50 and more than 25, and they say, well, we're going to buy a B because they get more margin utility from the first B than they would from the first A or the first C. Unfortunately, that's incorrect, because it doesn't take into account that the price of B is different from the price of A and the price of C. Yes, you get more utility from B than from C, but it costs you more too. You have to take that into account. So the way we take that into account is by calculating margin utility per dollar, which is the margin utility of the good divided by the price of the good. Excuse me, that's not right. Margin utility divided by the price. So for good A, price is 2. So the first unit of A gives them this much additional satisfaction, but it costs them $2. So the margin utility per dollar would be 25 utils, 50 divided by 2. And if they consume the second unit of A, they get 20 additional utils per dollar. That's 40 divided by 2, and so on. Stop me if I make a mistake. So those numbers would be the utility per dollar spent on good A, and we have to do the same thing for good B. We have to take the margin utilities and calculate the margin utility per dollar. So that for B would be 75 divided by 3, 60 divided by 3, 40 divided by 3, that's a 30 divided by 3, 20 divided by 3. What's that one? You're going to do the same thing for good C, but it's easy because the price is 1. When you divide all these by 1, you get the same number, obviously, right? So that would be 25, 20, 15, 10, and 7.5. So we calculated the marginal utility per dollar. So now our consumer Daniel has to decide whether to buy the first A and get this much utility per dollar, or the first B and get that much utility per dollar, or the first C and get that much utility per dollar, and they gets the same amount of utility per dollar for each one. So he really wouldn't care. Of course, he has enough money, $24, to buy one of each. So that's what he would do. He'd buy an A, and he'd buy a B, and he'd buy a C. The A costs him $2, the B costs him $3, the C costs him $1, and so if he started with 24, he just spent 6. So he's got $18 left. And since he's got money left, he'll keep buying stuff to increase his utility. So what's he going to buy next? He can choose the second A and get this much satisfaction per dollar, or the second B and get that much, and or the second C and get that much. In each case, again, they get the same amount of satisfaction per dollar. So since they have enough money to buy one of each, they'll buy one of each. Again, they'll buy another A and another B and another C, which costs them another $6. So now they got $12 left. So what are they going to buy next? Now we've got a different situation here. Now the third unit of A gives them 15 utils per dollar, and so does the third unit of C, but the third unit of B only gives them 13.3 utils per dollar, so they will buy the A and the C before they buy the B. If they ran out of money, that would be the outcome, but they still have money. So since they get more marginal utility per dollar from the A and the C than they do from the B, they buy an A and the C. The A costs $2, the C costs $1, so now they've only got $9 left. But since they have money left, they'll keep making purchases. And now Daniel has to decide whether to buy the fourth A and get 10 utils per dollar, or the fourth C and get 10 utils per dollar, or he can buy the third B and get 13.3 utils per dollar. So he does best if he buys the third B, because he gets more satisfaction per dollar from that than from the next unit of A or the next unit of C. So he buys a B, and now that's $3, and he's down to $6 left. So now what's he going to buy? The fourth A or the fourth B or the fourth C? He's going to be indifferent between them, and since he has enough money to afford all three, that's what he's going to do. He'll buy the fourth A, fourth B, fourth C, at which point it costs him another $6. 2 plus 3 plus 1, $0 left. Can't buy anything else. So the question is, how much of each good will Daniel purchase in equilibrium? And the answer would be 1, 2, 3, 4 units of A. 1, 2, 3, 4 units of B. 1, 2, 3, 4, 4 units of C. So he's going to buy 4 units of each good in order to maximize his utility. 1, 2, 3, 4, 1, 2, 3, 4, and at that combination of goods A, B, and C, the marginal utility per dollar he gets from good A is the same as the marginal utility per dollar he gets from good B, is the same as the marginal utility per dollar from the fourth unit of good C. So there's that balance between the marginal utilities per dollar that defines an equilibrium. He's maximizing his utility if he chooses 4 of each. His total utility would be 50 plus 40 plus 30 plus 20 plus 75 plus 60 plus 40 plus 30 plus 25 plus 20 plus 15 plus 10, whatever number that is. And no other combination would give them more utility than that number, whatever it is. Then the second question on this assignment is B, if the price of A goes up from $2 to $4, other prices in the budget stay the same. Now, how much of each is he going to buy? Well, if the price of A changes, we got to redo the whole exercise. Price of A's gone from $2 to $4. And that means the marginal utility per dollar he gets from good A will now be half as much as it was before. It's going to be 50 divided by 4 now, which is 12.5. And then it's 40 divided by 4, which is 10. 30 divided by 4, 20 divided by 4, 15 divided by 4. The marginal utilities per dollar for the other goods are the same because their prices haven't changed. Those are all the right numbers. Didn't do that very well. Yeah, so we're looking at the pink numbers now. The pink numbers show the new marginal utilities per dollar. And Daniel again has $24 to buy these goods. So what's the first thing he's going to buy? Is he going to buy the first A and get this much satisfaction per dollar, or the first B and get that much, or the first C and get that much? And the answer is he's going to buy the B and the C because they give him more satisfaction per dollar than the A does. 25 is both more than 12.5, so they're going to buy the first B and the first C. A B costs $3, C costs $1, that's $4, so Daniel's got $20 left. Since he has money left, he'll keep making purchases to increase his utility, and now is he going to buy the first A, or the second B, or the second C? And the answer is he would buy the second and the second B and the second C because they give him more utility per dollar, 20, than the first unit of A does, which is only 12.5. So they buy another B and another C. Indicate that with the green. Another B and another C, and that uses up another $4. So Daniel's got $16 left. And so what's he going to buy next? Is he going to buy the first A and get 12.5 utils per dollar, or the third B and get 13.3, or the third C and get 15? So the best thing for him to do now is to buy the third C. That gives him 15 utils per dollar, which costs him $1, so he's got $15 left. And now, is he going to buy the first A and get 12.5 utils, or the third B and get 13.3, or the fourth C and get 10? Now, the next best choice is the third B, because that gives him 15.3 utils per dollar. That costs him $3, so now he's got $12 left. And so now he's going to buy an A, because the first unit of A now gives him more marginal utility per dollar than the fourth B or the fourth C does, so he buys an A, which costs now $4, so he's got $8 left. We're almost done. So what is Daniel going to buy next? He's got $8 left. What's he going to buy with his $8? He can buy the second A and get 10 utils per dollar, or he can buy the fourth B, which also gives him 10 utils per dollar, or he can get the fourth C, which also gives him 10 utils per dollar. And since they give him the same amount of satisfaction per dollar, he'll buy all of each. And it just so happens he has enough money exactly to buy one more of each. 4 plus 3 plus 1, $8, $0 left. He buys the second A, he buys the fourth B and he buys the fourth C. So how much of each will Daniel purchase in equilibrium? He'll buy two A's. Oops, let's raise that up. How much of each will Daniel, if the price of A rises, he'll buy two A's. He'll buy four B's and he'll buy four C's. He won't change his consumption B and C, but the higher price, the price of A went up from 2 to 4. And the quantity of A he purchased goes from 4 to 2. And that, you come down here to part C, is using the information from parts A and B, draw a demand curve for good A, indicate price and quantity combinations. So a demand curve. What does a demand curve show? It shows the relationship between the price of something and the quantity of the something people want to buy. And I think I'll draw my demand curve up here someplace instead of down below. So we'll put our demand curve right here. This is the demand curve for good A. So the vertical axis measures the price of good A, and the horizontal axis measures the quantity of good A demanded. So we know that when the price of A was 2, Daniel wanted to buy 4 units of A. So if that point on the axis is $2 and that point on the horizontal axis is 4 units of output, then that point is a point on the demand curve. It's a point where the price, the price and the quantity you want to buy. And if the price is 4, he's going to want to buy 2. So if that is $4, and it should be twice as far up as 2. 2 on the horizontal axis should be halfway from the origin to 4. That point right there would be another point on Daniel's demand curve, and so Daniel's demand curve goes through those 2 points, and that blue line, whatever all that happens to be, that's Daniel's demand curve. So, in other words, this inverse relationship between the price and the quantity demanded, inverse relationship, price, quantity demanded, comes about as a result of a difference in marginal utilities. And that's that. Minutes.